Hi friends, welcome to this lecture on knowledge representation in artificial intelligence. So in this lecture, I'm going to cover why the knowledge representation is important. And guys, you may be having a doubt like or questions like how the machine or the AI based system learns from learns from the knowledge base, or how it is mapping those knowledge to certain things to derive information. And also you may be having some questions like what are the types of knowledge that the machine can learn. So also you want to explore the issues in creating a knowledge representation, right? So in order to gain knowledge on all these things and to answer all your questions regarding this, today in this lecture I'm going to cover this topic with insights on knowledge representation and mapping. Okay, so to make a machine or AI agent to perform a task in a better way, so it is necessary to create a better knowledge representation, so that the machine can utilize the knowledge to solve complex problems. For example, the chat GPT that we discussed in the previous lecture is designed to learn from natural language sentences. So then sentences are to be represented in some machine understandable form, or the system understandable, AI agent understandable form, right? So then only the machine can understand the information, and it can derive information to generate response to the user. It can communicate with the human being. Okay, so if you are solving a complex problem, it is necessary to create a large knowledge base, and you need to create a large representation of knowledge with the necessary amount of knowledge, and you must use mechanisms like forward reasoning or backward reasoning to derive the knowledge from the knowledge structure. So there are two things when we talk about this knowledge representation. We consider facts in the world, which are called truths in the programming world. We can consider some set of sentences which are representing the facts in the real world. So those sentences are to be represented in some form to make a machine to understand those things. And we'll discuss how the representation of facts can be done. So the representation can be done at two level. One is at knowledge level. So at knowledge level, we usually represent the facts in some form. So the facts may be describing the agent's goal and behavior, and at symbol level we will be describing the objects, and those objects will be represented in symbolic form to make a machine to understand those objects. And so there is a mapping between facts to representation and representation to facts. So if you are having English sentences for the given amount of knowledge, then we have to do the mapping from those knowledge to the internal representation, to English sentences. Also there is a mapping, backward mapping. So we have to apply this mechanism to perform the necessary operations on the knowledge. So this structure shows initial facts are converted to internal representation, and the internal representation may be of frames like structure or logical rules, or maybe production rules, we can say, or maybe semantic structure. So these are converted to another form after applying an operation of the program. So we are generating an internal representation, and then we do backward mapping to generate final facts. So from those things, the output of reasoning will be taken. So there are different kinds of knowledge, guys. We have declarative knowledge, inheritable knowledge, meta knowledge, heuristic knowledge, and procedural knowledge, inferential knowledge. So we'll discuss these types of knowledge so that you can determine what are the things you are going to consider for creating a knowledge representation. Okay, so in the declarative knowledge, we usually consider the concepts, objects to represent the knowledge. So we will be creating some sentences considering the concepts and objects. It tells what to do. It will be in the form of commands, for example. Okay, so this is data oriented. For example, the relational table that we create includes facts, describing objects and a set of relations of the objects. And for inheritable knowledge, we use a mechanism called property inheritance. The inheritance allows us to derive new information from the old structure. Okay, so we design a structure to apply this inference mechanism more effectively. So this provides a more powerful way of inferencing from the structure. We organize objects into classes, and we are having way of arranging the classes in a hierarchical structure, where you can use slot and flush structure or semantic net or collection of frames to describe objects and values of objects. So if you are having a frames, then each frame should represent the collection of attribute values associated with a particular object. The objects will be represented in the node. For example, in this structure, we have a simple relational knowledge representation to represent this creative declarative knowledge. So we have a simple relational table that describes information of players, attribute values of those players, right? So here player information is described like this. For example, player 1 and his height, then weight, also whether he is a left-handed batsman or a right-handed batsman. So all these informations are described for the player information. So for if you are describing a knowledge in inheritable form, then we'll be applying a property inheritance. Here you can see objects are represented on the nodes, and attribute values of those are linked to each of the node, and you can derive sub object from the main object or the super object, we can say. So here baseball player is the main object. So from that you can see we have easy relationship to another object, and for fielder we have easy relationship with this baseball player, and attribute values of each of these objects are linked here to that particular node. Okay, so from this knowledge structure, the mechanism, inference mechanism, backward reasoning or forward reasoning can be applied to derive the knowledge. So for each of the object, if you are representing in the form of frames, so we will be having an attribute value pairs like this, key value pairs of an object like this. So is denotes that the baseball player is an adult male, and bats whether it is equal to the batsman, and height of the player, batting average, all these are key attributes. On the left hand side you are having attributes, on the right hand side you are having values of those corresponding attributes. So this describes information about this particular baseball player. So this kind of knowledge structure need to be created. And another kind of knowledge is meta knowledge. This describes knowledge about other knowledge. For example, the title of the lecture, description of what has to be taught, right? So all those things describes the knowledge about the particular lecture to be delivered. So similarly, heuristic knowledge, these are experts knowledge. It can be like cost information to travel from one place to another place. If a person is an expert, he will be able to guide the tourists or the people to travel from one place to another. That kind of knowledge to be used for the system. And inferential knowledge, as I already mentioned, so we use property inheritance mechanism to do that. So sometimes in addition to this, we also apply traditional logic mechanism. As you can see here in this example, we apply first order logic, first order predicate logic. We use inferential, we use quantifier for all x, if x is a player, x is flying, and the ball is catchable, then whether the ball is on the fly or it is caught by the player, like that we are expressing the knowledge. Similarly for x and y, if x is better and x is better for another team, player of another team, then we check whether y is in the field. So whether the ball is caught or whether it is flying, so we check whether it is true or false. So if these conditions are satisfied, if the ball is not flying, then if it is caught by the player, then the player is out, like that. So we are representing the knowledge. So for procedural knowledge, we usually create functions in a programming language. The popular programming language for procedural knowledge representation is Lisp, and we use even C language to write a functions and all. So that shows process oriented knowledge. So for example, here in this example we are writing a procedural knowledge in the form of rules. So if a player is say playing for the ninth innings and the score is close to the target, and there are no outs, let's say a number of players out is less than 2. So maybe the next player, if he's a better player, then he will be allowed to bat, so to finish the game quicker, so they will allow the next batter to bat. So that's one of the example for representing procedural knowledge as rules. So there are some issues in the design of search program, guys. So you need to take care of these things, whether you want to apply forward chaining or backward reasoning mechanism, and how do we map these rules to facts, and how do we map these to the process, and you need to consider the way of representing the knowledge, whether it is to be represented in the form of node or to be represented in the form of tabular like structure. So you need to consider these things. These are knowledge representation problem. So if it is a simple problem like chess, maybe you can create an array to represent the knowledge, right? A node can be represented by a simple array. If it is complex problem, that may not be suitable. So we need to determine all of the of facts representing an action of an agent. So you need to create a better knowledge representation. And other issues may be, the attributes may be common to many of the things, many of the objects, so that may cause redundancy, and you need to consider the important relationship among attributes of objects. So if there are missing relationships, then that will cause problem. You need to take care of that. And at what level we are going to represent knowledge, whether it is at the symbolic level or knowledge level, so that has to be considered. How many objects you are going to involve in the relationship for describing knowledge, that also you should take care. And how can relevant parts be accessed? So this is another thing. Once the knowledge is stored, if you are having a large amount of knowledge in the knowledge base, how it is possible to access relevant parts, that has to be taken care by the programmer or the designer. So we consider some important attributes like instance or is a relationship to perform inferencing better. And there are some important properties for creating the knowledge representation. So we should check whether these properties are satisfied to ensure that the better knowledge representation is created for making a machine to understand and reason about the problem. Okay, so first one is representational adequacy. So here what we do, we represent all kinds of knowledge. So we should ensure that the programmer has represented all of the kinds of knowledge. So if there is a data insufficiency or knowledge insufficiency, then that will cause problems. So we should ensure this property. Another property is inferential adequacy. So here what we do, we check whether the program is having the ability to manipulate the representation in an easier way, whether it is able to derive new structures, new knowledge from the old structure, that we should ensure. So that's the next one is inferential efficiency. Here we make the program to derive new knowledge, and we focus on the inference mechanism. We are trying to improve the performance of inference mechanism by adding additional knowledge and all. Okay, so this gives better knowledge structure if you are adding new information to make the inference mechanism more efficient one. So we should ensure this property as well, inferential efficiency, in terms of time taken to process knowledge when you are adding the knowledge, whether the inference is efficient. So we should check. The next one is acquisitional efficiency. This describes the ability of an agent to acquire new information easily. So information may be retrieved from many different sources, maybe from websites, or maybe from sensors, or from other sources. So the system should be designed to acquire new information easily. So these are some important properties, guys, need to consider while creating a knowledge representation. Okay, thank you, guys. In the next video I will explore more about the techniques for knowledge representation, approaches for knowledge representation, logical representation, logical approach, production rules, frames, semantic net approach. So we'll discuss these knowledge representation approaches in the next lecture. Thank you guys.